Hey, this is Rusty Walker with NASRC. One of the things that makes CO2 racks a little bit different than an HFC rack, because when we think about it, once I get on the low side, it's almost exactly the same, just a little higher pressure. So one of the things that makes it different is managing that high pressure. People talk all the time, oh, I don't want CO2 because it's uncontrolled high pressure, whatever. So that's really kind of one of our myths of CO2. So the first thing I want to point out is the high pressure control valve. The high pressure control valve is going to manage my discharge pressure. It's going to manage where I am at. And it's going to manage and create, at certain times, it'll manage subcooling, or if I'm at a high ambient, it's going to manage my change of state as I expand my gas through here when it's super critical. So when people worry about this 1,400 pounds of pressure, I'm simply going to use the high pressure control valve to manage my condenser gas cooler coming into here, and I'm now going to put that liquid vapor that I've re-expanded into my flash tank. My flash tank is very similar to a receiver, but unlike a receiver where it just basically sits there at the pressure of the ambient, this I'm going to go ahead and manage. I want to manage that to about 35 degrees, around 520 pounds. I like to think of it more in temperature. And so I'm going to manage this receiver at that 520 or 35 degrees. And how am I going to manage that? I just come through the high pressure control valve. I've allowed it's 90 degrees out. I've come in through here 1,250 pounds. I've entered into the flash tank. How do I prevent that high pressure from entering the store? I simply use this flash gas bypass valve, similar to what I would use as an EPR, and I'm going to allow the vapor coming off the flash tank. I'm going to come out here and I'm going to take this flash gas and I'm going to dump it into the medium temp suction. And so I'm able to manage that flash tank at, again, the 35 degrees or 520 pounds, which means as I enter into the store through the liquid line, I'm going to see that my liquid temperature to my expansion valve is 35 degrees. So this allows me to manage the discharge pressure, it allows me to manage the flash tank as I come in here and I flash and separate the vapor from the liquid, and it allows me to maintain a liquid temperature at a very usable and low pressure. So now I can manage that liquid pressure. I can use L copper, I can use the standard copper that we typically use, and I don't have to pay the expense of an XHP copper, a high pressure copper. And so it makes it now, from now on, it makes it just like any other rack that any other technician has worked on.